Let us discuss about Kirchhoff laws. What is Kirchhoff law? What are the Kirchhoff laws? Those we'll discuss now. A German physicist, Gustav Kirchhoff, developed two laws enabling easier analysis of interconnection of any number of circuit elements. The first law deals with the flow of current and is popularly known as Kirchhoff Current Law, while the second law deals with the voltage drop in closed network and is known as Kirchhoff's voltage law, KVL. Let us discuss about KCL. What is the KCL law? The sum of incoming currents equal to sum of outgoing currents at a node in the circuit, that is KCL. The algebraic sum of currents at any node of a circuit is called zero. Circuit is zero. The sum of algebraic sum of all currents at any node, it is the node. Previously what we discussed, node. The sum of algebraic sum of currents at any node of a circuit is zero. That is, the sum of incoming currents is equal to sum of outgoing currents. While applying KCL, incoming currents are assumed to be positive, outgoing currents are to be negative. The sign convention is very important while applying KCL or KVL. Incoming currents are assumed to be positive. In this outgoing current, it is the incoming current I3. Outgoing current I2 is in outgoing current. Incoming currents are I5. I1, I4, I5 are incoming currents. I2, I3, I6 are outgoing currents. I2, I3, I6 are outgoing currents. For this kind convention, what we have to remember is incoming currents are assumed to be positive, outgoing currents are assumed to be negative. Okay, incoming currents are I1, I4, I5 are positive. I2, I3, I6 are outgoing, it is assumed to be negative. By applying KCL, sum of incoming currents equal to sum of outgoing currents, or algebraic sum of total current at any node is 0. I1 plus I4 plus I5 are assumed to be positive because they are incoming. That equal to I2 plus I3 plus I6, that is outgoing. If you transfer this to this side, it will become 0, that is summation I equal to 0, that is KCL. Next is Kirchhoff's voltage law, KVL. It is also called as mesh law. The law says that algebraic sum of all the branch voltages or voltage drops in any closed path is equal to 0. Voltage drop means V equal to IR. Algebraic sum of voltages or voltage drops in any closed path of network that transferred in a single direction is 0. ఒక డైరెక్షన్లో సింగిల్ డైరెక్షన్లో కరెంట్ పోయే సర్క్యూట్లో voltage drop is equal to 0, total voltage drop. అంటే suppose if it is a Vs, sign convention is important for this. It is a plus, it is a minus, it is a minus, it is plus. Now the current direction is like this, minus to plus, assume that. Now current direction is, it is a minus, it is plus. Current direction is, assume that, minus to plus. Now sign convention is, for Vs is minus to plus, it is plus. Minus nunchi plus like వెళ్తుంటే sign will be plus. If the current is moving minus to plus, that is negative terminal to positive terminal, it is plus Vs. Now the voltage across resistance R1, assume that a circuit having a battery and R2 resistance R1, R2, the voltage drops across R1 is V1 and voltage drops across R2 is V2. Now provide the dot conventions, minus plus, current entering is plus minus. Current entering means it is plus, leaving means it is minus. Now sir, the sign conventions for KVL or KCL, both cases sign convention is very important. If the potential is rising, assume that it is a plus, it is a minus, it is fall in potential. Now assume that it is a minus, it is a plus. Now the current direction, assume this in this direction, it is a rise in potential. When rise in potential is happening in this circuit, minus to plus, we have to assume that plus Vs. The sending source or source is Vs plus Vs, because it is raising potential, minus to plus it is moving. Current direction is assumed that current direction one direction, we assumed that it is in clockwise direction we assumed. Similarly for R1 V1, it is V1 voltage drop across R1 is. Now current is entering and leaving. Entering point is assumed as a positive and leaving point may be assumed as negative. Similarly for R2 also. Similarly for R2, the current entering leaving. For V3 R, it is also known as another resistance. It is V3 plus minus. Current entering is plus and negative is. Again same negative will be connected here. Similarly you can do it. We have to remember rising potential may be assumed as plus Vs, falling potential may be assumed as minus. Falling plus to minus, it is falling potential, hence it is minus V1. Assume that V2 plus to minus, it is falling potential minus V2. Similarly from that law KVL, from that KVL, total voltage drops equal to 0, Vs equal to V1 plus V2 plus V3, or you can send this to this side, then we can make it as 0. Vs plus minus V1 plus minus V2 plus minus V3 equal to 0. Therefore Vs minus V1 minus V2 minus V3 equal to 0. Therefore sending in voltage equal to total drops, or we can say that summation of voltage drops equal to 0. Total algebraic voltage drops equal to 0.